Good morning, everyone. In this video, we will be discussing about links and associations. Okay, so we'll discuss about links and associations, their basics. Okay, we will also be looking at the multiplicity, and we will also be looking at association and names, and then ordering, and then what are association classes, and then qualified associations. Okay, let's go through each of them one after the other. So a link is a physical or a conceptual connection among the objects. Okay. So during the last video, we have seen how classes can be represented and then how objects will be represented. Say for example, person John actually works for GE company. Okay, so you can actually define such a link between these two objects. John as a person is the class, and then John as an object. Okay, and similarly, company is a class and GE is an object. Okay, so and then there can be a link between the two. Okay, works fine. Similarly, a link can be also for say for example, a person can John can own stock of a GE company. You can also define it like that one. Okay, that's a link. An association is a description of a group of links with common structure and semantics. Okay, so the same thing. So that means say for example, these are the different objects, okay, from this class, and these are different objects from this company class, and you have multiple links, isn't it? And an association basically describes these links completely. Okay, say for example, you can have an association something like this between the classes then. Okay, so basically a person is a class, and then a company is a class, and then now you have an association like an owns stock. Okay, or say for example, a person works for a company. Okay, so you can have such an association. Okay, links of an association connect the objects from the same classes. Okay, say for example, this is an association which is an own stock. Okay, it can have several links, but these links associate. Okay, so these links actually connect the objects of person and company classes. Okay, so that's how we define links and associations. Okay, associations and links often appear as verbs in a problem statement. Okay, so that is something to remember. An association describes a certain set of potential links in the same way like we actually describe a class describes a set of potential objects. Okay, so we have to think in that lines. Always associations are bidirectional, mostly. Okay, associations are bidirectional. In real, both directions of traversal are equally meaningful and refer to the same association. Okay, say for example, if going by the same example earlier, a person and a class, basically person works for. Okay, so then basically from the other end, a company actually employs a person. Okay, so the associations are mostly bidirectional. You can implement associations as references from one object to the other. Okay, we'll be seeing those things in Java programming language as part of the labs. Okay, you have to wait for a week or two before you actually understand these concepts, but associations are implemented as references. Okay, these associations can also have multiplicity. Okay, so earlier in the figure, you might have seen a person and a company had these stars. Okay, multiplicity actually specifies the number of instances of one class that may relate to a single instance of an associated class. Okay, okay, UML diagrams list multiplicity at the end of these association lines. Okay, say for example, if there is a class called country and then a capital city, there is an association. Okay, and then it had multiplicity of 1 and 1, so it is basically a one-to-one mapping. Okay, one-to-one association. So basically one country is associated with one capital city. Okay, so similarly this is the class diagram, and then similarly if you think in terms of objects, say for example, India as a country is an object. Okay, it has a capital. Okay, so which is New Delhi. Okay, so we have object from country class and also an object from capital city, and then that is how they are related in an object diagram. So the above one is a class diagram and the bottom one is an object diagram. There can be different types of multiplicity. So as the figure is shown, like it can be exactly once. Okay. So for example, a country can have exactly one capital city. Uh, yeah, I mean, like you can actually ask me, like, okay, so certain country having multiple capital cities, or like, okay, certain states having multiple capital cities, or blah blah blah. Okay, so that all depends on your modeling constraints. Okay, so if your model basically allows that one, a different multiplicity level, and then like the design itself will change. Okay, you have to think in those lines. So different multiplicity types. Okay, so if we come back, like exactly once is represented like one. If you have one or more, okay, so then you can represent it like one dot dot star. Similarly, like if you want to represent more than one, okay, or like a certain number of them, say for example 2 to 5, if you put as multiplicity, that means like either 2 to 5, so it can be 2 or 3 or 4 or 5 inclusive of both 2 and 5. Similarly, like if you want to allow only 0 or 1, okay, so then you will basically put like 0 dot dot 1. Okay, so the same type you can use. So the star, if you put, it basically shows like multiplicity with many. That means like 0 or more. Okay, so this is about multiplicity. So if we, let's continue this multiplicity further. Okay, a pair of objects can be instantiated at most once per association. Okay, so remember this one. A pair of objects can be instantiated at most once per association. But then there are exceptions. Bags and sequences are exceptions, which we'll be discussing in the coming slides. Okay. We can also model multiple associations to model multiple links between the same objects. Okay. From the beginning example, like we had this sort of a class. Okay. Say for example, one class is this person, and then the class is this um, what is that, company. Okay, so then we were always thinking about two associations possible there. Okay, one is like a person can works for a company. Okay, and he can own a stock as well. So then there can be a first association, an association, and then like there can be another association. Okay, between two classes. Okay, so it is possible, and you can model them like that. Okay, see here the multiplicity is star and star, that is many to many association here. Okay, uh, I already have mentioned it. Okay, multiplicity always depends upon assumptions and how you define the boundaries of a problem. So a person, you can actually define it like a person works for exactly one company, or like a person can work in multiple companies as well. It is possible. Okay, say for example, a tax board basically asks you like how many companies you work, how much salary you have earned, and then like you have to basically pay for that one. Okay, but whether you want to allow such a thing, like say for example a person working for multiple companies, would you like to allow or not? It depends on your model and then like your design. Okay, so that's how like multiplicity actually depends upon assumptions. Okay, how you actually define these boundaries for a problem. So these associations may also have these sort of end names. Okay, if you put those names, the name actually appears next to this sort of association end. Okay, especially convenient for traversing associations. Okay, say for again going by the by our example, a person works for a company. Okay, so a person, okay, many number of persons can work for a company. Okay, and a person is working for either working, if at all, if he is working, he is only working for one company. This is the association which we are defining. Okay, so a person is an employee for that particular company, and then like a company is an employer for that particular person. Okay, you can treat these association and names, okay, as pseudo attributes for the other one. So from the viewpoint of the source object, traversal of an association is the related objects. Okay, so from the person you can actually reach the company, okay, through these association and names, and similarly like from a company you can actually reach the person. Okay, so we need to remember these things. Associations also have these sort of end names. Um, they are especially necessary for associations between two objects of the same class. Okay, say for example here is a class diagram where like we have a user, okay, and we have a directory, and then like say for example there is an association between directory, from directory to the directory itself. Okay, it is called self association. Say for example a directory may be container, okay, which actually have several other directories within it. Say for example, one directory can contain several other directories within it. Okay, this is how like you actually define your file system, isn't it? So if this is the case, then basically association and names basically give you additional information. Okay, so basically like it is a container. Okay, a directory is a container for a lot of other directories, which are actually contents of that particular directory. And see this multiplicity as well. So either it can be one directory can have multiple directories as contents. These association and names also distinguish multiple associations between pair of classes. So let us see here. Say for example, there is a user and then like there is a directory. A user can be an owner for a directory. Okay. In this case, like this is an association with the one star as multiplicity, one to many. Okay. So basically, like a user is a owner of one directory, but there can be several authorized users for a directory. Okay, probably you all know about Unix systems. Okay, so most of you are you have Ubuntu on your laptops. Okay, so you know about these relations. Okay, so basically, like a user is a owner for a particular directory, and then there can be multiple authorized users who can access that directory. So in this case, between these two classes, there are multiple associations between these two classes. Okay, and then like the association and name is the one which is actually perfectly distinguishing them. Okay, so you can model them like that. If you think, okay, so often the objects on a many association and have no explicit order. Okay, so basically like if there is one to star association, okay, one to many association, okay, there is no explicit order for in certain cases, but sometimes they may have an explicit order. Say for example, in this case, think like there is a screen class and there is a window class. Okay, and then like there can be multiple windows which are on the screen, but only the top window is actually visible on the screen. Okay, say for example, if okay, most often like in certain operating systems, like you will be showing only the top window, okay, which is the visible. Then you need some sort of ordering of these window objects, okay, which one screen is associated with. Okay, so if the association is visible on, then you need an ordered set. Okay, so basically like if that is the case, then you can actually define the ordering for those association objects, okay, by putting this sort of ordered in curly braces. Okay, this is about order. Then there are also these bags and sequences also possible. Generally, a binary association has at most one link per pair of objects. This we have already discussed. Okay, I also mentioned at that time like there are exceptions with these sort of bags and sequences. Let us look what they are. Okay, we can permit more by annotating an association and with this sort of bag or sequence. Okay, so bag is a collection of elements. Okay, duplicates are also allowed. Okay, so I will give you an example. Okay, so this itinerary and then like airports, I will discuss it in detail. So a bag is a collection of elements. Duplicates are also allowed. Okay, and sequence is an ordered collection of elements with duplicates are allowed. Okay, so think about this one. So itinerary is an object. Okay, is a class. Okay, and then like airport is again a class. So it is a many to many relationship. So itinerary is like how you are actually traveling. Say for example, if I'm traveling from Hyderabad to Estonia, Tartu, okay. So basically, like the travel will have the complete travel itinerary will have multiple hops. Okay. Say for example, I have to travel from Hyderabad to Delhi, and from Delhi to Helsinki, which is in Finland, and from Helsinki to basically Tallinn, which is the capital of Estonia. Okay, so that is like, so if you think in terms of that is the flight itinerary. Later I have to take a bus and then like may have to go from Tallinn to Tartu. Okay, where like University of Tartu is there. From there like I have joined University of Hyderabad recently. But the point is, so within this itinerary there are multiple airports. Okay, say for example you are starting from Hyderabad to Delhi, Delhi to Helsinki, Helsinki to Tallinn. Okay, there are multiple airports are there. Okay, and there can be multiple itineraries as well across different airports. But the point is, okay, there may be a situation, okay, say for example within a single travel I may visit that airport several times. Okay, so think about, like, say for example, like within a single travel, like I have to travel from Hyderabad and then like have to visit Frankfurt in Germany, and then like say for example then I have to go to Hong Kong. Okay, and then like have two conferences, one in Frankfurt and the another one uh, in Hong Kong. Okay, attend them. Then what I will be doing? So I'll be traveling from Hyderabad to Delhi, and from Delhi, like I will be going to Frankfurt. Okay, assume like there is a direct connection. Okay, so we'll be going to Frankfurt, and I will attend that conference. Okay, whatever it is, and then like I will fly back from Frankfurt back to Delhi, and from Delhi I will go to Hong Kong and come back to Delhi, and then come back to Hyderabad. In this case, like say for example, I am visiting this particular Delhi airport several times in this single travel, isn't it? How can I represent that one? Then sequences are actually perfect for that one. Sequences is an ordered collection of elements. It will allow the duplicates. It will also allow, okay, in which particular order like I am traveling. Okay. So if you go back and see this ordered relation, ordered is like you will have only, say for example, particular windows coming in the order, but you cannot have duplicates. Okay. With this sort of sequence, you can have these sort of duplicates are also allowed between these associations. Okay, it's all about how you actually design your application. Okay. The example which I have given is for the travel application. So until now, like we have seen like associations as just representation on these sort of association lines. Okay, but then like sometimes the associations can also have attributes. Okay, say for example here we were discussing about person and company, and a person works for a company. Okay, so in UML, like say for example, you represent such information with this sort of association class. This is how you actually represent association class. Okay, with dashed line between the association. So here you can see like a person has a name, birth date, and then like address, and similarly like a company has a name and address. But then like a person is working for a company, works for a company, then he has a certain job title and a certain salary associated, isn't it? So you have to represent this sort of relation, okay? So association using this sort of association classes. So association classes can have their own attributes, their own operations, and also like they themselves can participate in further associations. Okay, so for example, this class may be associated with something else. Okay, why? It depends on the domain and the like the particular case study. Okay. Actually, it is possible to fold the attributes of an association for one to one and one to many into the class opposite to the one end. Okay, so for example, if you basically think about the same thing, okay, a person. So, for example, like you can actually fold these sort of salary and job title, okay, as attributes into this person. Okay, and then like the works for will be the simplest association possible. Okay, so you can actually fold these attributes into this one, because this is one to many or like many to one to many or one to one cases. So basically like you have to put here is one, okay, multiplicity for company. So you have to fold these things, fold these attributes into this person class. That is actually possible, but there are certain catches with that one. Okay, but if you have a many to many relation, you cannot actually fold it. Fold these attributes into this one of these classes. Okay. So as a rule, do not fold these attributes. Okay. So if they qualify to be an individual association class, maintain them as an association class. Okay. Because the point is like during the design, at any phase, like your multiplicity may change. Okay. Then what do you do? Say for example, in this example, like if this becomes like a star to star, okay, many to many, you allow multiple persons to work in multiple companies. Okay, then if you had put this variable as well, these variables as well into a single person, then how do you define salaries and job titles? Will you maintain an array? Okay, so a lot of changes will happen. So it is better that don't fold these attributes into this sort of person class. Okay. association class has only one occurrence for each pair of associated classes. This is something that you should remember. So then let's look at the next feature, which is like qualified associations. Qualifier are actually part of association ends. Okay, qualifiers. Say for example, think about the situation. You have a bank as a class, okay, and then like you have an account, okay, and then like each account has an account number as a feature, okay, as an attribute. Now the point is, each bank will be associated with multiple account numbers. But the point is like, okay, qualifiers basically disambiguate the objects for a many association end. Okay, say for example, a bank can have multiple accounts, but the thing is like, think of the situation, if there is a bank and if you put an exact qualifier like an account number for that particular bank, that will associate to exactly one account, isn't it? So there is an SBI bank, and if I give you an account number as well, that will basically link to exactly one account if it is existing, or like there is no account existing, isn't it? So this is what you can actually model with these sort of qualifiers. Okay, these qualifiers are possible for the cases of one to many and then like many to many associations. Okay, um, these qualified model basically, as I have explained, this qualified model adds a multiplicity constraint. Okay, so exactly as I have explained in this case of bank and then account, having an account. So this is about links and associations. Okay, so this is the reference for that one. So this is again from chapter 3 of this object oriented modeling and design with UML. Okay, Michael Blaha and Jameson Walpole. Okay, so this is from chapter 3. Thank you very much for your attention.